Hello, folks. Good morning. My name is Pradeep Gowda, and I'm going to be talking today about this fundamental question that especially in the beginning of our web development career, or even sometimes after having done it for quite some time, we want to be able to grow our applications and keep it running for a long time, in ever-changing circumstances. So I would like to talk about that today. Just a little background about myself. I've been programming in Python since about 1998, professionally since about 2002 or so. Most of the time, Python has been my favored programming language, though I do programming in other languages. Member of IndyPy since 2008. This has been my web sort of a background in Python. Started with Zope and Plone, and then discovered Django around 2006 or 7-ish. Then I went through various sort of combinations of frameworks. Currently, I mostly do development in primarily in Scala and Java and in Django. So recently, I developed a web service for my employee that is of collecting millions of events a day. So essentially, it collects data from all over the world. It is an API primarily. So I would like to share some of the things that I have learned over the years, and especially in the past project that has helped us scale well and then perform in a good manner. So that application is built on Django, and then we used Ansible for deployment. We used Prometheus and Grafana for monitoring and alerting. So I'll talk about all this in detail. So what are the themes of this talk? So essentially, how do we grow your application beyond, hey, I have a web application, let's say you start with something like Flask or Bottle or Django, you followed the tutorial or watched talk, and then your application says hello world now, or it does something more impressive than that, actually solves a business problem for you, and then you're now thinking about, okay, so how do I make this live for a long time, help my team sort of maintain it, grow it, and all those considerations. And then I think the essence of being able to do all of this with confidence, I think is very important. And then reduce toil. Toil is a recent sort of it's not a new word, obviously, but it's a recent phenomena in the DevOps and the service reliability engineering world. The focus there is to reduce toil, obviously. We'll talk about what it means to have toil in your environment, and then how to reduce those things. And then the other important factor is observability. So today we deal with tens, maybe even hundreds of services, even for what we call as a regular or normal application. We have a lot of dependencies on services that are run by our own teams or other teams or even other companies. And then our applications may be depended on by other teams and other companies. So how do we get sort of insight into what our applications are doing in production, and how that helps us have a confidence in our application on an ongoing basis? These are the themes of this talk. A lot of this might sound familiar to you, especially if you have been familiar with things like the 12-factor app. On the right, you see the 12 factors that were sort of put forth by practitioners a few years ago. In this talk, I will be touching some of these. So things like maintaining your code base in a version control and dependencies. So I'll go into some of this in detail, because of course we want to build upon the learning that we have had over the years. So definitely some of these things are a lot more important for the current context. So touching on some of these. And then of course, the whole software world runs, or at least desires to run on the DevOps model, wherein the developers and the operations team work in tandem. They support each other, and we want to support each other so that their applications run forever, as long as they need to run. and at the quality of service that makes our customers happy. So one of the important considerations, in the DevOps world is if a human operator needs to touch your system during normal operations, you have a bug. The definition of normal changes as your system grows. So when you have 100 users, how your system behaves may not be sufficient when you have, let's say, 5,000 users. So this is an important criteria to keep in mind when we talk about the purpose of DevOps. So again, what is Toil? So Toil is work tied to running a production service that tends to be manual. For instance, many years ago, and even now, some teams still do deployments manually. They do a lot of the steps in the life cycle of a software in a manual manner. That tends to be Toil. I mean, we are programmers, and we should always try to see how we can do it with manual steps. That's definitely the number one item that can reduce your toil. And then do repetitive things. So again, computers are really good at this. So why can't we, make the computers do the repetitive stuff? And then, of course, automatable and not requiring human judgment. So this again, if you are doing the same thing over and over again, is there a way to capture that in a program or a script, so that way we can automate it? And of course, if you have done any kind of operation support, you realize that it is very much an interrupt-driven and reactive occupation. So you never know when the pager duty alarm will go off. It may be 3 o'clock in the morning, or in the middle of your very productive coding zone. Well, you have to respond to it, and then you have to react to it. So this essentially sort of stops us from working on things that have long-term impact and on good things and positive things. So definitely we want to reduce toil. And of course, often toil, this kind of work has no enduring value because we are not building new products. We are not adding features to our products. So this often doesn't have enduring value. So if you want to read further more on toil, I have been very much impressed by the concept and also how they characterize this. So these are the two. The first one is eliminating toil. This is on the Google SRE webpage, and the second one is Invent More Toil Less. It's next 2016 paper, both by the same team of SREs in Google. They're very good papers to read, so you should definitely peruse it. So next, I talked about confidence. So essentially, when do I say that I'm confident about my services? Well, it is done in the first place, and then it works, and then it works not only on my machine but actually on systems that are in production or in other environments where other people actually get to see it. And then it works, more importantly, it works for the whole team, which includes you, the developer primarily, your QA team, your ops team, and customer support team. Probably the last one to a lesser extent, but it should work for the entire team or teams, but not just for you and maybe just the developer team. So this is the kind of confidence that we want to build for your application. So what gives that kind of confidence? If I can do the same thing again and again 100 times, it's repeatable. That means okay, it is working as expected. There are no weird cases where it works 30% of the time, but the other 70% of the time it doesn't. I mean, that's pretty bad. But so being able to do the same thing again and again, that's good. Reproducible, that is, you're able to do the same software deployment, or it works the same way on your machine or in production or in a different system. So it is reproducible, both the features and the bugs. So that is important. So being able to reproduce the same features and bugs is an important thing. And change with ease. So one thing we have to remember is the minute you start working on a new feature, your current software, you should think of it as obsolete because you're already working towards removing that from production. I'm not saying the whole software is obsolete, but the specific version that you're deployed is already, has writing on the wall. So how do you manage that kind of a change? So being able to do that with ease gives you a lot of confidence. And of course, things change around us. AWS outage, service outage, library upgrades, third-party library upgrades, that is. So how do you handle all those things? Being able to handle all this with ease and predictability is what gives us confidence. And incorporating all these things that we learned into future scenarios so that we are not caught short, we are not surprised that often, and by that degree is a great thing. So that's what confidence means to me in this context. So when you talk about reproducible, we are talking about lowercase reproducible and not uppercase or a capital reproducible, because you can take reproducible to various degrees. Something like Nix, which is like immutable infrastructure. Essentially, you're saying that your entire system, is reproducible. You can literally bytes are the same on any machine that you deploy. So I think that's a great goal, but I think that's still very much something that people are trying to understand better and implement in their systems. That's probably a future goal. Maybe in a couple of years, we'll see that widely adopted. But I think right now we are trying to achieve slightly lesser degree of reproducibility, but still important ones, like, pinning dependencies. How often are you surprised by the fact that your web application depended on a third-party library, and then they change something in that newer version, but then you have not pinned down your software to a specific version of their library, and then now you have broken software because you didn't know what version you used in the first place to develop your system, and then of course hopefully take it through QA and deployment. Nothing has changed, but something is broken. So pinning dependencies to specific versions of your upstream dependencies is a very important thing. Now we have the technology to do it, and we should use it. I'll get to that with an example. Definitely, operating systems. I mean, this is pretty much a given these days that you develop on your local system like a Mac or a Windows. But then you expect it to, the gold standard for running is where it runs. So probably a Linux system or a BSD system. Being able to say that, okay, it works on this version of operating system is a confidence boosting thing. So make sure that you have the same version of the operating system throughout all your environments. And then when I talk about environment specifically in the context of Python, I talk about things like virtual env and virtual environments because it's been known for probably close to a decade that installing packages and dependencies and your software into system Python is definitely not a good thing to do. It's not recommended. So you should use things like virtual env or virtual env wrapper both during development as well as in production to make sure that the same environment exists for your application. So pinning dependencies. So this is a very common thing. I mean, but if you didn't know, pip can help you pin down the dependencies using requirements.txt. You should definitely use that. There are other solutions like pip env. This is what I have used in the recent past, and I have had good success. And again, one of the complaints about Python is that the packaging systems, in fact, all the attempts over the years, none of them are perfect, and they all have different degrees of brokenness. So I think you need to figure out what works really well for you. In my experience, pip env has worked pretty well for me, so I would recommend that. I have not seen any big issues with that. And then there is a newer thing like Poetry. I have been trying to use this on a newer project. One of the things that Poetry does really well is make the packaging of your application into installable wheel. Things like that is much easier with Poetry. But again, it's still new to me, and it might be new to many of us. So it's something that you want to take for a spin. But these are probably in the order of most well-known to least well-known. So you may want to start with something as stable and well-known as requirements and pip, and then slowly explore other options. But definitely, you should be using one of these things. This is a little too small to see. I hope I can just read out some of the things. This is a pip file. So basically, this talks about all the packages that I'm using for my project here. Okay, that's much better. So here, actually, you can see that I'm not explicitly pinning down the dependencies, but then when you do run this pipenv against this file, it installs the latest versions of the software, and then it generates a log file, and that file basically is the what is used for developing your software. So you can carry the same dependencies through your rest of the environment, so that you can say that I developed this software on the specific version of, let's say, Python decouple and Django or whatever. Let's say I use 2.1.1. I know that it worked on the develop environment and QA on that version, so we should use the same version and subsequent all the dependencies using the pipfile.log. So that's one way to capture the specific versions that used without having to manually, handpick everything. And again, you can see at the bottom, it says requires Python version 3.7. This is another thing that I always emphasize. Use the most recent version of Python 3. If you're still using Python 2, that's probably a bad place to be in, because the weight of your technical debt is probably getting heavier and heavier. So see what you can do to mitigate that. And definitely for greenfield projects, you should start with Python 3. I would say Python 3.7 is been out for quite some time now, so you should start using 3.7. Unless your operating systems, there are some operating systems that still don't ship with 3.7. I think even the 18.04 Ubuntu and things like even CentOS, maybe they ship with 3.6. So 3.6 is still good, but if you can use 3.7, you should definitely use that. So that's all to make sure that you have your environment pinned down to the specific versions when you're doing development, and you're able to carry that through. Also, another thing that you should pay attention to is packaging our applications. So a lot of times people think that since Python is a scripting language, I should be just able to copy this particular file to location on a server, and then hey, that's my packaging. But then again, you are not getting the benefit of being able to say this version of my script depended on these specific versions. So you're losing all that information when you just throw a script somewhere and then say that hey, it should work. It won't a lot of times. So pay attention to packaging your application so that it is deployment ready from day one. So write your setup.py files on day one when you start your hello world, and then keep that up to date. And then and these days the setup.py is actually pretty well understood. It is not a very complicated thing to write, and as I mentioned, things like Poetry can actually make it easy to package that up. So definitely look into those things. And think you should definitely look into things like using console entry points, so that you can actually run your application as a standalone program versus that also has all the dependencies as part of the deployment, and not just a one-off script. Definitely use continuous integration and build systems. I believe there are talks subsequent to this that talk about these. Definitely use this not only for packaging your applications, but also for testing and other things. Versioning, definitely you should version your software. If you don't know what version you're running in production, then you really don't know what is running. You'll be surprised how many times people just copy over the tarball of the code repository and then say, hey, this is the latest code. But there are ways to find out what exactly is running, but then you really want to depend on that. You should really be, explicitly stating, especially when we talk about code deployment tools, you'll be able to say, use this specific version of my software to deploy into the lab system or the production system. So it's not that difficult to do. Typically, you can use the version number, something like version.py, or you can use your build system to increment the version for you. And the key thing here is, the same version build should travel through the various environments. Assuming that you have a dev system that can be a laptop, or it could be a hosted system, and a QA and staging and production, the same binary file or the tarball of the source, since we are talking about Python, it should travel through all the environments. You shouldn't be having one build for dev and another build for staging. That makes no sense. So yeah, these are the 4 stages that a lot of people follow, but of course you may not have all the 4. Sometimes you might have only 3 of those: dev, QA, and prod. I mean, less than 3, I don't know, it's not very confidence inducing. So see if you can create at least dev, QA, and production environments, so that the purpose of having a separate QA environment is that you are recreating your whole environment from scratch for QA, and you're not sort of tainted that environment by developer fiddling. And it also draws a line in the sand saying that, okay, now I'm actually handing it over to you, so you do the testing and tell me if it works for you or not. So the QA might have more integration tests and stuff like that you may not have. So it definitely makes sense to have 3 environments. So, and testing, this is another touchy topic. I mean, of course, there is a whole ecosystem, and there's a whole belief system around, TDD. There is test-driven development and how you should do your tests. Definitely, that is something that you should do. But again, it is not as difficult as it is made to be by some people, especially because it is such a confidence booster. And this is why you should do testing, because you have worked on a code base and you went away for 3 months, and then you came back and want to add a feature. Now you don't even know, what has changed in the meantime. Assuming that tests were kept up to date, you can actually assume that, okay, so now if I'm going to add a feature, I can be sure that, I didn't break somebody else's stuff. So if not for anything else, you should do it for the confidence that it gives you, of being able to move fast or move slow and not break things. Also, testing can serve as the documentation, and this is especially true for APIs. I have personally found this to be one of the greatest side benefits of writing test cases. I often just send the a link to the test file to our QA team saying that this is how I tested this. And if you say something is broken, can you tell me what the test I have, especially the integration test, can we change this or improve this? And obviously, if they do find a breaking thing, then I go and add one more test. So these are some of the side benefits of having test cases. You should definitely add as much tests as you can stand and needed. And especially in case of regressions, you should add more tests just to make sure that you're not, basically you can say with confidence that you fixed it. So testing need not be very complicated. This is a very simple test case where I test if my JSON, API endpoint is actually returning a 200 code. This is not a very complicated code. So I'm sending a token, and then I'm getting a response, and I'm testing if the status code is 200. This is a very simple test, very basic test. Of course, I can get into detail about what JSON was returned and whether it had a particular field, and if that field had a specific value that I was looking for. Of course, you can go into that. You can have it as part of the same test, or you can have multiple tests at different levels. But as you can see, this does actually document what the API behavior is. So if you're developing web applications, doing an API first development is probably a good idea, and I would definitely say it's a good idea. And adding test cases like this will allow you to express what the API does and documents it for good. The next thing I want to talk about is the environments. I talked about the 4 different environments that many development teams use. The central idea is that you have one code base, but you deploy into multiple environments. Again, this ties back into reproducibility, and you should drive application behavior through configuration, not through code change. That means if you have the same binary for all the environments, so how are you going to change the behavior? That is, how are you going to tell your application you should use this particular database string for QA versus production? So that means that behavior change is coming through configuration and not an embedded hard-coded database string in your application code, which probably is a bad idea because those kind of things tend to leak, and when they leak, that can be a security issue, that can be a loss of data issue. So make sure that your configurations are specific to the environment, and that changes the behavior of your application. So one library I did find very useful is called Decouple. So what essentially this does is allows you to specify your environment specific configs in a INI format or even env style format. I like the INI format. So you put in your values specific to that environment. In this case, let's assume that this is the QA environment. So I would definitely like to see some of the debug statements. And if something fails, maybe I want to see what happened in the response. So definitely I want to set debug to true. And then in the actual settings file, this is a Django example, by the way. So in that case, I would like to, by default, I wanted to set it to false, but then specific to the environment, I want that value to come from the settings.ini file. So this allows me to essentially, override config values using a simple config file instead of using a Python script or Python file, which sometimes the Django's choice of using a Python file for setting configurations is not a great. Sometimes you feel it's not a great idea, but so using something like Decouple allows you to essentially circumvent that and then use just configuration files for changing your configuration. So use Python Decouple. That's my recommendation there. And you should definitely use a deployment tool to install the environment-specific configurations. We'll talk about that next. Definitely use an automation tool to do your deployments. SCPing stuff back and forth and installing dependencies on the operating system, whether apt get install Python or whatever. It's okay when you're doing the first time, but it soon becomes too much to keep in your head. So use one of these. I use Ansible these days, and I also use Puppet and actually Chef. Actually, I use all of these in different environments, but for the project that I was talking about, I mentioned earlier, we used Ansible. So Ansible, I like Ansible. It makes sense to me, and there are other frameworks like Salt. I believe someone else is going to talk about that. But use any one of these, whatever is supported by your team and your company's ops team, use that. They all have different levels of difficulty and ease of doing things. So use what works best for you, but use it. Definitely, the repeatable part is so important because essentially the same role or deployment script works for all the environments, which is pretty magical if you think about it. You just run one command, assuming let's say you're using Ansible, you literally say, Ansible, whatever, install this playbook, and then it's one command, you've got everything taken care of. The operating system, the application deployment, the cron jobs, your web services, the log rotations. There are literally, like tens of things that you need to do to get an application running these days. And all of them can be deployed on multiple systems in different environments with one line shell command. And I think that is a great thing. And of course, the deployment scripts are self-documenting. Some people do use scripts to automate or at least capture the stuff they do when they deploy stuff. But I would say, unless you're doing something very contextual, use a deployment tool. I mean, scripts are helpful. Scripts can actually be part of your deployment tool. You can always call a script from within Ansible or Puppet, but then resist the urge to do things manually and through scripts. So my recommendation is start the automation along with your coding. So let's say you have two repositories, one for your actual application, another for the deployment. I think they should probably start at the same time. So as soon as you have something to sort of show, it can be just one API endpoint, or it can be just the homepage of your application. So if you have that, and if you want to show that to somebody, that's the cue for it to start writing the automation role. So don't delay it, because then you'll just gather a lot of things that you might forget. So think of automation as primarily a documentation tool when you start developing things, and then it makes your life so much easier after that. So this is one of my, I want to set the stage for one of my favorite things. So we are all creatures of habit, and then we're also sort of used to remembering things when we are in a particular place. So I want to sort of use that to sort of pitch for the use of something like Make. Make is one of my favorite tools. I know people are always talking about Make. Oh, it uses tabs and not spaces, and who uses tabs these days? But you know what? This is literally a Make file from my project, with obviously my name's changed. So this is what I use as a contextual memory helper. So I don't remember the exact incantation to run my test cases. Once I do it, once I figure it out, I just put this in a Make file. And next time I want to run a test, I just say Make test. And then same thing with the packaging. I want to package this into a source distribution. So I just say Python 3 setup.py dist, but then why should I remember this next time? I put in the package command, and then I say make package. So once you have the steps in a project figured out, and you should definitely put that in a make file so that you're documenting, because obviously you're going to commit this with your code into the repository, and it helps other people to know what all things you can do in this project. So in this case, with the source code, you can test it, you can package it, or maybe build and copy to a different place. This is a local package and copy, but then you can even run it from your CI. So you can tell your Jenkins job to basically run, package, and let's say deploy to your local PyPy. Let's say you have that is Python packaging index, or maybe you have Sonatype Nexus, one of the or JFrog, or any of the binary artifact distribution things. So you can tell your CI to do that. So one for your local development, one for your CI. And Makefile is a great way to do that, because it's probably 40 years old at this time, and there are plenty of books, plenty of videos, and this probably exists on every system that is Unixy. So use a Makefile. If you want more evidence or more argument for using Makefiles, I recommend reading this article. This is by Mike Bostock. The interesting thing is he's probably well known for his excellent interactive graphics on New York Times. So he's what you call as front-end developer, but you can see, he uses this all over the place, and he highly recommends it. And that particular article is a really nice way of explaining why make sense. So next we'll get into the next big topic, that is observability. So gain visibility into the behavior of applications and infrastructure. So this is very critical. This is where you help your ops people, and this is where they become friends with you, or they continue to remain friends with you, because they're helping them know what went wrong, or at least are the things working fine. And if something does goes wrong, and ultimately it will, eventually it will at whatever, 3 a.m. in the morning. So you're going to help yourself and them by making your system more observable and not a black box, okay? So the production environment is, it's multidimensional, it's always changing, maybe the user behavior is changing, or the dependent systems are changing, so you don't know. So if you can't observe what's happening, then you're at a loss to explain what's happening. The inputs might be changing. Suddenly you start getting people who use UTF-8 instead of just ASCII characters. So how do you know what's happening? So definitely you want your system to be observable, and also it's always not the upstream dependencies that bite you. Sometimes it also may be downstream dependencies. One of your customers suddenly became hugely successful over, let's say, the NCAA basketball weekend or something. You can never predict any of these things. And then how can you say, okay, so which customer is now creating all these hotspots? Who is sending me all this, a million requests now? If you don't have it instrumented, then you have to, I don't know, maybe dig into the server, start looking at the logs or something like that. So why not put this in from the first place? So one thing that can help you there definitely is logging. So what's a log? It's basically an immutable record of discrete events that happened over time. So there's a time component, there is, it's a record component, and it records what happened, and then of course, it's about events that actually took place. But the trick is, what to log. I mean, one of the common things I've seen is that people use wrong log levels. So the quick rule of thumb is debug is what you should use. Anything that that you're printing before, like if you're using print statements, just use debug. Info is what you want to use when you want to confirm when something happened. Let's say you want to basically confirm that the data you sent to a third-party API actually was received and they sent you 200. Maybe you want to log that as a debug or info depending on the traffic, but maybe as info if it is important enough. And then warning, definitely something that should have happened, but it's not a deal breaker. That should probably go into a warning. And the error definitely, this is definitely like a deal breaker. Like you're not able to connect the database, or another service that you're depending on is sending you a 500 or a 404. That's an error. So learn the different levels of logs and then learn to use them. And definitely, as I mentioned before, avoid print statements because they're not very helpful, especially in a web environment. They may be useful in local, but then it really takes a few character chains to convert that into a debug statement, and you can always tail that log file to see what's happening. And it also has the benefit of telling you the timestamp and exactly what method, and plus you can actually take it through all the environments, and you don't have to again go back and delete print stuff. And then, for example, this actually is a thing that I had done in my code. Though I often don't do this, but I found this code when I was preparing this presentation. The problem here is, you can see I have an except block here that says file not found error. Actually, I'm not doing anything. I'm not actually printing out or capturing in a log what exactly the error was. So this should probably be changed into except file not error as E, and then use logging.warn and then actually print the error. So catching the exception itself is not enough. In many cases, you actually need to log what exactly the error was so that you can help yourself to debug the issue. So especially in production environment, it's not good enough to say that, okay, something happened here. That's usually a lot of how the log comments look like, but then also print the actual error so that you know what exactly happened. So and then one of the most important things for a web application to keep track of is the request ID, because when you have hundreds and thousands of requests coming in, you definitely want to sort of thread the needle through the same request. The same log file might have all mixed up requests, so you definitely want to put a unique ID for each request so that you can track what happened. And then essentially this adds a unique ID to each request. A lot of times you get that through the Nginx or load balancers, so you may not have to add this yourself. But if it doesn't, then you can always add a request ID yourself by using something like request ID library, and then add your WSGI app. And then, of course, there are different kinds of logging. The most common is plain text. And then structured logging is what I would like to mention a little bit here. And then binary, we'll not talk about that because that's probably more for systems. Low-level systems. Essentially, with structured logging, you can capture just about any data. And then it also allows us to capture all the details that we're interested in. And you can do things like actual data analysis on the logs. You can audit what happened, when something happened, who did that, and what did they do. Those are really important for auditing. And then you can actually do analytics. So how is all this possible? So one of the most common ways to do structured logging is through JSON. That is, you actually log all this stuff, higher dimensional data, as a JSON, and then you can pipe this into something like Splunk or Elk Stack, and then you can do analysis on that. You can create dashboards. This is especially useful if you're dealing with tail events that happen probably like once in a million requests. So if you have structured logging, you can actually use your tools like this to search through those and help you sort of pinpoint what exactly happened in that point in time in that event. So you can use something like struct-log library for Python. So essentially the output of this would look like this. This is not JSON, but then this format is well understood by a lot of the log parsing systems like Logstash. So you can use this or you can use JSON. It's really up to you depending on what you're more comfortable with. Excuse me. So this shows a JSON logging. Of course, these libraries can also do things like they can filter the additional things, like here, for example, when password is masked so that it is not shown in the log. So when we talk about logs, we also talk about metrics. They're very important. They are the set of numbers that give information about a process or an activity. This also tells you how many things failed, how many things succeeded, rate of growth over time, and then any patterns that are of interest to you. I recommend Prometheus, and if you look at, Prometheus has very good documentation. Go look at this. Essentially, this is a time series metrics system that allows you to capture things like this. In this case, you can see that it is capturing what are the number of total number of HTTP requests that are post sent to this particular endpoint, and the count is 3582. So those many requests were received by that endpoint. And this again. So the good thing about this is Prometheus is not very heavy on your system. It's very lightweight. You can install on all your nodes. It doesn't really increase with complexity as you grow your application. It's pretty simple. The best thing about Prometheus is a pull-based system. That is, your external systems will pull data from your node instead of you trying to push. Sometimes you can run into problems when there's network issues and things like that. So this is how you configure, for instance, a Prometheus endpoint on a Django application. So you can see, I have a metrics endpoint that exports all the different endpoints that I have configured. There are some that come with frameworks like Django, but then also you can write your own counter. For example, here I'm just counting something called the state transition counter, and then this would appear like this in the Prometheus metrics page. So this is actually a different metric, but you get the idea. Oh, it's actually here. So what metrics to collect? You want to collect definitely the request rate, the error rate, and the duration of requests. This is good for 95% of the monitoring alerting. We'll probably run through some of this. So what's the difference between logs and metrics? Logs are events, metrics are aggregates of events. Logs tend to be high dimensional versus low dimensional for metrics. Logs are really unstructured, metrics tend to be very structured, as we saw. And then logs are good for analysis of what went wrong and things like that. And metrics are really good for dashboards and alerting. And these logs vary in volume depending on the behavior of application. Metrics tend to be very fixed. Okay, and also logs are very high volume, metrics tend to be very low volume. So Grafana is software for time series analytics that creates very pretty dashboards. So this is actually a masked, redacted dashboard from one of our Grafana dashboards. You can see that all these are sort of tasks that run one after the other, but you can actually see the same pattern repeating after each other because they consume the data from the previous step. So you can see that at one snapshot that all of them are actually running fine and they're running without any lags and things like that. There's a lot that you can understand from a good dashboard like that. Alerting, definitely people use something like alerting when something goes wrong, but I would recommend using Grafana alerting because I found it much easier to instrument and send out alerts. Like this is actually a snapshot from the email I got when a job failed. So just to go back, so these were the themes of my talk. I hope I covered most of these. If you have any questions, feel free to reach out to me on email. This is my email, and that's also me on Twitter. I'll be very happy to answer any questions you have on Twitter.